All right, so I think this is recording. Let's take a look at solving this problem. It's a word problem. It's a mixture problem. How many ounces of pure water must be added to 50 ounces of a 15% saline solution to make a saline solution that is 10% salt? So let's first do this by this bucket method. How many ounces of pure water? So water is being used to dilute this 15% solution down to a 10% solution. So we've got water. We're measuring saline, so there's no saline in pure water. How many ounces of pure water? That's going to be my variable x. Must be added to 50 ounces of a 15%, 50 ounces. And this water dilutes this 15% down to 10%. And by adding these two volumes together, these two containers, we have a total number of ounces of x plus 50. So in this bucket method, we multiply the concentration times the volume. 0 times x is just 0. We've got 15 times 50. We have 10 times x plus 50. 15 times 50, I think, is 750. Distribute the 10 through. 10x plus 500. Subtract 500 from each side and divide by 10, and we have that 25 ounces of our water will dilute the 50 ounces of 15% saline solution to create 75 ounces of the saline solution that's at 10%. So let's shrink this up and let's do this same problem, only by that method that they refer to as a seesaw method. So in this seesaw method, we want to identify the weak concentration, identify the concentration that is in between the weak and the strong. So since we're measuring saline, the weak is definitely the water. The in between is the 10%, and the strong is the 15. So we don't know how much water that we need to use, and we do, however, know that the strong was 50 ounces. Okay, so we're interested in the formula for the seesaw method. Is coming kind of from at least I think, from an idea in physics of if you have a seesaw and you have a balancing point they refer to as a fulcrum. You have the weight of some heavy object, the weight of a lighter object, and if you balance, you have that from the fulcrum, you have some distance, and then from the fulcrum here, you have some distance. So you take the weight times the distance and set it equal to the weight times the distance, and that's what we want to do here. So the distance between this 0% and 10%, the difference, 10 minus 0 is 10, and the difference here, 15 minus 10 is 5. So we're going to take the this volume here, this X, and multiply it by 10. And we're going to take this volume and multiply it by 5. So we have that 10x is equal to 250, which gives us the same answer that we had before, that the number of ounces of our pure water of our weak solution, that we need 25 ounces of good old high quality H2O. All right, so I hope that helps, and I will talk to you later. Bye.